A buffer solution is a solution that can resist the change in pH when a small amount of acid or base is added into it. This is an important process or reaction which requires specific and stable pH range. Buffer solutions have a working pH range and capacity which dictate how much acid or base can be neutralized before the pH change. Examples of buffers are blood that contains a bicarbonate buffer systems, and also in many household products. For example, an adult shampoos are buffered to prevent the skin irritation by components like sodium hydroxide. In order to maintain the pH range effectively, a buffer must consist of a weak conjugate acid-base pair, meaning either a weak acid and salt with its conjugate base or a weak base and salt with its conjugate acid. A buffer is able to resist the pH change because of the two components, which is the conjugate acid and conjugate base that are both present at equilibrium and able to neutralize the small amount of the other acid and base when they are added into the solution. To clarify this effect, we will discuss it later. An acidic buffer is a solution that is made up from the weak acid and a salt that contains the same conjugate base. For example, if we have a weak acid, which is an acetic acid, that are mixed with a sodium acetate salt, the sodium acetate salt will dissociate completely in water to form the acetate ion and also the sodium ion, while the acetic acid is a weak acid which will dissociate very slightly in water to form an acetate ion and hydronium ion. Since this weak acid and salt contains the same conjugate base, this solution is a buffer solution. The conjugate base will become a basic species, while the weak acid will become an acidic species. To calculate the pH of the acidic buffer solution, we are going to use the Henderson-Hasselberg formula, which is pH is equals to pKa plus log concentration of conjugate base over concentration of a weak acid. Remember, pKa is equals to negative log Ka. The concentration of the conjugate base equals to the concentration of the salt, since the salt will fully dissociate and form the conjugate base ion. When a small amount of strong base is added into the solution, weak acid will neutralize it. The weak acid will donate its proton to the base and form the conjugate base. This will make the concentration of the conjugate base increases and the concentration of the weak acid decreases. The equilibrium position will shift to the left to increase the concentration of the weak acid. Thus, the pH is not much affected. When a small amount of strong acids is added, a conjugate base will neutralize it. Thus, the concentration of the conjugate base will decreases and the concentration of weak acid increases. Since the dissociation of the weak acid is really small, the pH is not much affected. Basic buffer solution is made up from the weak base and salt that contains the same conjugate acid. For example, if we have an ammonium chloride salt, okay, and also the ammonia mixed together, the ammonium chloride will fully dissociate into the ammonium ion and chloride ion, while the ammonia, which is a weak base, will slightly dissociate into ammonium ion and the hydroxide ion. The ammonium ion that's present in both solutions is the same conjugate acid, so this solution is a buffer solution. To find the pH of the basic buffer, we need to calculate the value of the pOH by using the Henderson-Hasselbalch equation, which is pKb plus log concentration of conjugate acid over concentration of the weak base. The concentration of the conjugate acid is equals to the concentration of the salt, since the salt is fully dissociated and form the conjugate acid ion. When a small amount of a strong base is added, the conjugate acid will neutralize it. So the conjugate acid will react with the base to form the ammonia and also water. Thus, the concentration of ammonia increases and the concentration of the ammonium ion decreases. Since the dissociation of a weak base, which is the ammonia, is very, very small, the pH is not much affected. When we add a small amount of strong acid into the solution, a weak base, which is ammonia, will neutralize it. Ammonia will react with the strong acid to form an ammonium ion and water. Thus, the concentration of the ammonium ion increases and the concentration of ammonia decreases. The equilibrium position will shift to the left to increase the concentration of ammonia. Thus, the pH is not much affected.